In section 6.1, we're looking at ratios and proportions, and the second part of 6.1 we'll be looking at geometric mean. Ratios and proportions are something we did deal with in algebra, but now we're bringing in some more complex things with this and looking at geometric aspects as well. Now, a ratio, is a comparison of two numbers, and there are different ways to write ratios. The most common way is with that colon between, and we write it just A to B. It's comparing two numbers, 4 to 5, 3 to 2, 1 to 7, whatever it might be. Another way to write a ratio would be as a fraction. And these are going to be really the only two that you're going to use in geometry or in math in general. A to B with a colon between, or A to B as a fraction. But you can also literally write the word 2 in between those two quantities or those two numbers as well. Example here. Let's look at the ratio of side lengths in triangle ABC to triangle DEF. The reason I put this example as well is because look at the order that they put these in. They want triangle ABC first, then compared to triangle DEF. So make sure that you're picking a side length from triangle ABC first. The second number would come from triangle DEF. Notice triangle ABC is over here. So if I wanted to compare this side of 3, I would compare that to which corresponding side in triangle DEF. Well, it would be with this side 6. And if you're not sure which sides to compare, again, you can look at like the statement here. AC was the side with 3, and that was first and last letter. I could look first and last letter. Here would be DF, and yeah, that side is 6. But one thing that you should be familiar with is ratios are always expressed in simplest form because we think of them as fractions as well. It's another way to write them. So 3 to 6, we divide both of those by 3, and we actually get the ratio 1 to 2. And then maybe I could look at comparing a side length in, again, triangle ABC comes first, so maybe 4 would be compared to 8. And maybe this time I'll write it as a fraction, but again, that reduces or is equal to 1 to 2. So again, either way to write your ratio here. And finally, in ABC, side 5 would compare to the side 10, side FE there, again, 1 to 2. Now, all of these ratios, 3 to 6, 4 to 8, 5 to 10, are equivalent ratios because they have the same simplified form. So 3 to 6, 1 to 2, 4 to 8, 5 to 10 are all the same because they all reduce to that 1 to 2 ratio. Again, make sure you write it in the way that they state. When you talk about simplifying ratios, one super important thing is that you do need like units, because your answer should have no units. You should not have feet, inches, yards, whatever it is remaining in the answer. You need like units. You need them to cancel because you're simplifying. You should only have numbers in your ratio answer in general. So if I want the ratio of 24 yards to 3 yards, if you think of it as a fraction, and I'll abbreviate yards here, 24 yards to 3 yards. The reason why you don't have units is because anything on top and bottom will cancel out. Now 24 to 3 also reduces. Divide top and bottom by 3 and you get 8 to 1. Be careful that you do leave the 1 in the answer because it's not just a fraction, it is a ratio. I do need both numbers, so don't just write that as 8. We do want to write it as 8 to 1. Or again, you could write it as a ratio with a colon. 8 to 1 would be fine as well. In this next example, I have different units. 150 centimeters is going to be compared to 6 meters. Now, the units are not the same, so they won't cancel. What you're going to want to do is, if you have different units, multiply by a conversion so the units cancel. Now, I can multiply by a conversion by anything that's the same because it would be like multiplying by 1. If I want centimeters to cancel, it is on top, I need to put it on bottom. If I want meters to cancel, since it's on bottom, I need it on top. And then I say, well, how many centimeters are in a meter? There are 100 centimeters in 1 meter. So I write it like such. Now centimeters will cancel because it's on top and bottom, and so will meters because it's on top and bottom, and I won't have units anymore. Multiply across here of 150 times 1 is just 150. 6 times 100 is 600. And then I have to reduce. And actually, 600 does divide by 150, or I could divide by 10 and still divide by 15, or 150, and I end up getting 1 to 4 as my simplified ratio. Again, no units in that answer. Let's look at one more of that type where the units are different. So I'm trying to reduce the ratio of 36 inches to 9 feet. Again, I don't reduce right away. These are different units, so the ratio is not technically 36 to 9. I have to figure out what those numbers would be if the units were the same. Multiply by that conversion. I'm talking inches and feet here. I want inches to cancel, so I'm going to put it on bottom, and feet to cancel, so that goes on top. And I know there are 12 inches, in this case, in 1 foot. Now my units will cancel because they're on top and bottom. And 36 times 1 is just 36. And 9 times 12, gotta check that, it is 108. And then I want to simplify as much as possible. And actually 108 does divide by 36, and it's 1 to 3. Alright, so once again, canceling those units by multiplying by a conversion to simplify your ratios. And ratios should always be written in simplest form. A few conversions that you'll want to know for the homework today. There are 16 ounces in 1 pound, 5,280 feet in a mile. These are actually all ones you should know. And there are 4 quarts in a gallon. So be ready to use those in the homework today. And a little question, a little discovery for you. Can you find other ratios equivalent to 4 to 5? Could you give me 2 other numbers that are still in the ratio 4 to 5? And I'm guessing, hopefully a lot of you are thinking, well, how about 8 to 10? Because that would reduce to 4 to 5. And how did you generate 8 and 10? To get 8 and 10, really, didn't you just multiply the 4 and the 5 by 2? Can you think of another ratio equivalent to 4 to 5? How about 12 to 15? And that one, didn't you just times by 3? 4 times 3 is 12, 5 times 3 is 15. These are still all equivalent to 4 to 5. How about another one? How about 16 to 20? Because really, all you're doing is multiplying 4 and 5 by 4, and you get a new ratio. Well, wait a second, is there a way to generalize? What about every ratio in the world that would be equivalent to 4 to 5? So in general, could you tell me every ratio that would be equal to 4 to 5? Well, here we multiplied both by 2, multiplied both numbers by 3, multiplied both numbers by 4. As long as I multiply 4 and 5 by the same number, the ratio will still be equivalent to 4 to 5. But if I want to generalize any number in the world, what do we use to generalize any number? A variable. So what if I did 4 times x? Then I would also have to do 5 times x. Because here, 8 was just 4 times 2, and 10 was just 5 times 2. We multiplied both those by the same number. As long as I multiply both by x, this ratio, this would cover everything in the universe that's in the ratio 4 to 5, because I'm multiplying by the same number to both. Like here, it'd be like 4 times 3 is 12, 5 times that same 3 is 15. So whatever number you pick for x, as long as it's the same number and you multiply 4 and 5 by it, this ratio will still be equal to 4 to 5. And we're going to have to use this to solve problems today. So let's use ratios to find dimensions. In this example, it says the perimeter of a room is 48 feet. And the ratio of its length to its width is 7 to 5. Find the length and width of the room. Well, I'm just going to put a little rectangle in here quick. Now I know the ratio of length to width is 7 to 5, so that would be like the length being 7, the width being 5, but does that necessarily mean the numbers are 7 and 5? No, they could be, 14 and 10. I multiply them both by 2. Could be 21 to 15, multiply them both by 3, but in general, if the length to the width is 7 to 5, doesn't that mean 7x to 5x? 7 times something to 5 times that same something? So I'm going to generalize the length and the width as 7x and 5x. Because I have some additional info. I know the perimeter is 48 feet of this room. Now to find perimeter, don't you just add up all the sides? Here I have 7x and it's a rectangle, so you have another 7x. You have a 5x and another 5x. Let's add those all up. So we really have 7x plus 5x plus another 7x plus another 5x. So maybe I'll just multiply this by 2. But I know that the full perimeter, right, 2 7x's, 2 5x's, all added together is, they told me, 48. So this perimeter here, either finding it by x's or knowing it's 48, let's figure out what x is. This is really 2 times how many x's? Well, 7x plus 5x is 12x. So 2 times 12x equals 48. 2 times 12x is 24x. And that equals 48. Hey, look at this. All I have to do is divide by that 24 on both sides, and I'll get the x, and 48 divided by 24 is 2. Cool. Now that I know that x is 2, I can tell what the length and the width is. If x is 2, 7 times 2, this is 14, it was feet, right? Yep. So 14 feet for the length. 5 times that factor of 2 would be 10 feet for the width. And let's check, is the perimeter really 48? Well, 14 and 10 is 24. There'd be another 24 added to that perimeter, and we would get 48. So using that generic ratio to generalize to anything in the world that would be 7 to 5 helped us solve here. And let's try another example of that. This time we know that the area of a rectangular garden is 108 square feet. And we know the ratio of the length to the width is 4 to 3. Find the length and width of a fence enclosing this rectangular garden. Okay, so once again I am dealing with a rectangle. The ratio of length to width is 4 to 3. Oops. But remember, that doesn't mean that the numbers are 4 and 3. It could be anything in that ratio. So to generalize to anything in the world that's 4 to 3, I would have to multiply by the same number. So let's multiply by x to both of those. 4x and 3x would cover every ratio in the world that's 4 to 3. Oh, I guess the other way to think of it is as a fraction, right? If you wrote 4x and 3x, the x's would just cancel. See, it is still 4 to 3. Anyway, now that I identified length and width as 4x and 3x, I could be any factor of 4 to 3 ratio. I can use the fact that we're talking about area is 108 square feet to find what the x is so that I can find the length and width. Well, I know to do area of a rectangle, you just do length times width. So in this case, since the area is 108, I'm putting that here, that must equal length times width, which is 4x times 3x. And now I got to figure out x here. Now 4x times 3x, 4 times 3 is 12, and x times x is actually, careful, x squared, right? X times x. Let's get x squared alone by dividing by 12 on both sides. And I find out that x squared is 9. And now to undo squared, of course, I take the square root of both sides, and I find out that x is 3, right? Square root of 9 is 3. And I'm almost there. I just need to find the length and the width. If x is 3, then this would be 4 times that 3, or 12, we're talking feet again, for the length. And 3 times 3, this would be 9 feet for the width. And let's check, is the area really 108? Well, 12 times 9 is 108, and we're good to go. So again, using that generalized ratio to help me find a length and width. And one more example here, and this deals with actually extended ratios, meaning it's not just A to B, it's like A to B to C, or even further. It's using a ratio, but more than just 2 numbers being compared, it could be 3 or more. In this case, we're talking about a triangle's angle measures are in the extended ratio of 1 to 3 to 5. Find the angle measures. Well, if we're talking about the angle measures in a triangle, what do you know about the angle measures in a triangle? I know the angles add up to 180, right? Triangles angle measures. I know they add up to 180 degrees, and they're in this ratio of 1 to 3 to 5, so find the measures. Well, obviously we can't have 1 degree, 3 degree, 5 degrees, because that does not add up to 180, that adds up to 9 degrees. But I can generalize to anything in the world that would be 1 to 3 to 5, as long as I multiply 1 and 3 and 5 by the same number will still be in the ratio 1 to 3 to 5. So I'm going to do 1 times x, 3 times x, 5 times x. That's my ratio that would generalize to anything in the world. That would be 1 to 3 to 5. And now, what do I know I can do with these three, angle measures now in this case? I know that these should add up to 180. So this first angle, which is x, and the second angle, which is 3 times that x, and the second angle, which is 5 times that x, all added together should equal 180 degrees. Combine my like terms. I have 5x, 3x, and another x. So that would be a total of 9x equals 180 degrees. Divide by 9, and I figure out that x equals 180 divided by 9 would be 20. So x is 20, that factor that we're multiplying 1, 3, and 5 by. So plug in 20, find those angle measures. The first angle really is just 1 times 20, or 20 degrees. The second angle is 3 times that 20, 3 times 20 giving me 60 degrees. And finally, the last angle is 5 times that factor of 20. 5 times 20 is 100 degrees. And let's make sure this works. These angle measures are in the ratio of 1 to 3 to 5. And do they add up to 180? Yeah, 160, 80, 180 degrees. I want you to use extended ratios to solve this problem. Similar type, we have the measures of angles in a triangle in a new extended ratio of 2 to 3 to 4. Find those angle measures for class tomorrow.